We'll be talking about role of artificial intelligence in cloud computing. To hold this session, we have Mr. Subrahmanyam Lanka, Senior Vice President, Digital Health, Siemens Healthineers. Yeah, if I'm right, wrong. To give you a brief introduction, sir, are you there? Yes, you're there. Yeah. Hi. Welcome, sir.
Thanks a lot. Thanks for calling me for this.
I'll give you a brief introduction of you, sir. So, Mr. Subramanian joined Siemens in 1995. Since then, he has led the research and development of product for different imaging modalities, healthcare IT, healthcare enterprise IT solutions, and laboratory diagnostics. He is a postgraduate from IIT Kharagpur. Before joining Siemens, he worked with Bajaj Auto Limited and the India Space Research Organization. Over to you, sir. We're looking forward to hear from you now.
Okay. Thanks, Anamika. Thanks for the introduction. And you can hear me clearly?
Absolutely.
Absolutely. Right. So I will start, lack of time. Now I'll jump into straight away into the content of the presentation so that we catch up with the time. Okay. So I will share first and tell me whether you're able to see. You're able to see now?
Just a second. Yes, sir. Absolutely.
Yeah.
Yeah.
Okay. So I go ahead now.
Right, sir.
Okay. So thanks a lot once again. And I come from this healthcare background. So I will be touching upon this role of artificial intelligence and on cloud computing from a healthcare tech perspective, and how healthcare is benefiting from this, and then how healthcare is using these technologies and to shape further future of the healthcare. So this is where we go ahead. And then before I start anything, this is a very familiar picture where the patient will be asking the doctor on two fundamental questions. What is my problem? How am I? And how does the doctor understand this? And he requires a lot of information about the patient to understand what is the real problem with the patient. Then, if we have the correct diagnosis, we can have the right treatment. So if you go wrong in the diagnosis part, we go wrong on the treatment part. So this is very important to understand. The diagnosis has to be correct. So the answer of how am I has to be perfect. Then the next question will be, if the diagnosis is correct, what is the right treatment? What is my path to health? How long it will take? How much money I have to spend? What is the cost of this healthcare? And then so many questions. And what happens after the treatment? Will I be fully recovered? And will I be fully back to the health? All the major diseases once gets in, then these are all the concerns of a particular patient. So these are the two fundamental questions which really drives the entire healthcare system. How am I and what is my pathway? If you can answer them correctly, both on the diagnosis side and on the treatment side, using all the technologies which we are having today, then that's how the future looks bright. So we needed to ensure that this technology is what we are talking, whether it is AI, whether it is cloud, how it is helping this particular scenario, and then how these two questions could be answered. Now, I wanted to spend some time on whether such kind of questions are answered in any other domain, so that we can learn from that and then apply similar kind of solutions. I wanted to bring it to this particular picture. It's very familiar picture, If we want to go from some place to another place, we always used to look at a map and then see where am I and what is my path to that particular place where I wanted to go. This is where the map was used to answer these similar kind of a questions. Now we are all now using Google Maps, and then this is very easily answered nowadays. Where am I and what is my next step? And it will also tell you what is the optimal path, and it also tells you exactly how much time it will take for me to go to that particular destination. And once the destination is reached, it will tell you that you are at that particular place. So similar problem, where am I and what is the next step? And then if we can somehow apply similar kind of technologies and then try to solve our problem in healthcare, then that makes life wonderful. So, but there are challenges. Healthcare has lots of challenges, and let's look at those challenges and why it is so difficult to answer those two fundamental questions. Look at the situation. Our population above 65 years globally is phenomenally increasing it. And there is a lot of shortage of the physicians at the same time. So there is a demand supply gap which is not allowing our physicians to spend quality time or the right time to do the right things to come to the right diagnosis or coming to the right treatment. So this is a major problem, a demand supply gap. And if we can somehow help our physicians with the task through AI or cloud computing and allow that particular time for them to spend with the patient so that they gain a lot of knowledge about the patient so that they can really give right diagnosis as well as the right treatment. And secondly, there are a lot of data points which one has to look at it before one can come to real decision of what is the right treatment, how long it will take. And so these are all the lot of data is required to come to that particular decision point. And lot of decisions also were taken in the entire pathway of the particular patient journey. And many patients are also actually Am I audible now?
Yes, you are audible.
Okay, seems to be fine. Now let me bring back my. Okay, I go ahead and then the many patients are communicating with the doctors digitally. They refuse to go, or they're more preferring to go on a digital way. For example, COVID, nobody wants to go to the hospital, but somehow they would like to get the consultation from the doctors for their problems.
So your screen is not visible.
Screen is not visible,
Yes.
but I try to share the screen. Is that now visible?
Yes, yes.
Yeah, thanks a lot. Sorry for that. There seems to be an internet problem, and then heavily raining in Bangalore, and then got disconnected. Anyhow, so glad that I could join back. So I continue with these challenges, and there is a non-availability of the patient data. 50% of the patient's information, whenever it was required to be given to the doctors so that they can really find out what is the real problem and also what is the real solution in a treatment path, there is no data that is available at a central place. In India too, we have to carry all the patient records of the x-rays and then etc on a physical format. It will not, we don't know when those records were taken and then how to use them, basically, if the records are not available for us. And in the hospitals also, there is no proper data management strategy to collect all these records and then give a proper what I would rather call it as a treatment plan based on the data. So these are still the challenges. So with respect to the healthcare world, and then when these challenges are there are so many steps a patient has to go through. Fundamentally, I already listed down there. Whenever the patient comes, he needs to come with his history so that there is the right diagnosis, and only once we do the right diagnosis, there could be right therapy decision. And once there is a decision, okay, this is the therapy which needs to be administered or this needs to be followed, then the real treatment, and once the treatment happens, then there is a follow-up course of action. So at each and every step, lots of decisions have to be taken. Now look at what the problems in this decision making process is all about. 50%, as already said, report that the information was not available when it is needed for the. So we needed to bring that complete history first, either using the cloud and then afterwards using it for the diagnosis purposes. Then on the diagnosis side, as I've already mentioned, as one of the challenge is that the load on the doctors is pretty high. There is a shortage of the doctors, but at the same time, too much load on them. So that only makes the life difficult, and then that also brings a lot of errors. There are a lot of diagnostic errors because of which, and then if those diagnostic errors happens, then it's going to be a difficult situation for the patient. So we needed to ensure that somehow help these physicians and the doctors through our clouds and then the AI to reduce the load on them. That's where the diagnostic precision. So once we have the AI based solutions, we can really reduce a lot of load, and also the preciseness with which it can be done also increases a lot. Then the therapeutic decisions. Because a lot of data is required, too many decision points, too much of data needs to be collected to really come to what is the real treatment that can be prescribed to the particular patient, and then that is also not available. So we needed to aggregate all that data so that it is available at the right time, and also it is used for the treatment decisions. The diagnostic errors, or if it happens, it can also happen that wrong treatment will happen, a right kidney and a left kidney. On the treatment table, anything can happen unless otherwise you use the technologies correctly. And again, the medical data is phenomenally increasing, and then we need all this data. When it is increasing, we also need to ensure that this data is used to make the decisions. And obviously, as I said, that a lot of people wants to follow up on a digital sense, so they would like not, they don't want to go to the doctor every time. Somehow, if we can help the patients and the physicians to meet digitally, that will also make a decision making process much smoother. So these are all the Raleigh changes. Again, I'm coming back to the original questions, two questions, and then these are all the real challenges. How am I, and what is my path to health? And then if you can answer all these questions through either through cloud or through the AI, then I think we will be able to answer those two fundamental questions. So background is always that. So can we answer this? Can we overcome all these challenges with the digitalization through the cloud, through the AI? Now look at this. In a traditional healthcare, the doctor is always put at a higher pedestal. Patient does not take any decisions related to his health. It is the doctor who tells that this is your problem and this is what is your path to the recovery. Patient is not knowledgeable. It's no longer in a situation, if you can somehow empower the patient, if you can somehow empower the doctor to be on the same level of information, so that they can come to the real decision based on a collaborative manner, saying that, okay, how do we take this kind of a decision, and then so that you can afford it, and also you can be confident that this is really taken based on the data and not based on certain knowledge which the doctor only possesses it and nobody knows about it. So this also helps, but this requires a transformative change both by the doctors to accept that, okay, I can use AI and the data, and so that I can share, and then the doctor, but the patient is also empowered at the same time, saying that this is based on certain data, and then not by just by having certain understanding only the doctor only knows. So this is where the transformative change when it comes to the AI and then cloud. Again, we can somehow collect all the data. The data is growing exponentially, but we can all collect it and put it in a cloud. And but it can be seen that the data does not do you any good unless it converts into knowledge. And how do you convert that into knowledge? Is through the artificial intelligence. So let's look at it, that particular way of looking at that. What are the real steps in the cloud and in the AI for the healthcare domain, or specifically here, medical devices? They generate lots of data, and laboratories generate lots of data. Once this data is generated, it is important to put them in an aggregated manner, in a structured manner, so that we can utilize that data and then convert that into knowledge which can be used for the both the diagnostics and as well as the therapeutic decisions and also the rest of the follow-up processes. So generation, aggregation, analyzing, and then operationalization. These are the 4 fundamental steps, both in the cloud used for the aggregation and analyze is for the AI part of it. So data becomes a very crucial aspect of this. And as I said, the data can be through your wearables, it can be through your genomics, it can be through your lab, or it can be through the scanners in the medical technology. So most of them will generate lots of data. You aggregate them. Again, there seems to be some problems with my technology, and then every time power is going off, and then so am I visible and am I audible now?
Yes, yes. Visible and audible, and screen is also shared. You can continue, sir.
Sorry about that. Where, yeah, I'm here. And the data plays a very crucial part in coming to those cloud and the AI to solve those 2 fundamental problems. So this is where we need to leverage the data with the help of the AI. Now I come to the specifics of how this data is aggregated in a healthcare world. We have the home monitoring systems. We have the physicians who also external physicians, basically. I mean, in the clinics where they collect all this data. So where also a lot of data is of the patient is collected initially, and then obviously when there is a major disease, the hospitals, one has to go and then find out that there also data is generated from there. So all this data actually is required to really answer the fundamental question of how am I and where I'm going to be in my path to recovery. So this cloud plays a very important role in the healthcare world to aggregate this particular data. So this is where the cloud is coming, and then it has to be secured because it is all private records, and then no patient would like to share his data with anybody, and especially when it comes to the health. So we need it to be absolutely ensure that the data privacy is secure and data privacy is followed. So once we have that, then I'm coming from a very Siemens Healthineers specific perspective here on 2 AI solutions, one for the diagnostic purposes of different abnormalities and also organ specific abnormalities, and then how once we know all that decision, that how to take a decision in the treatment side. One is to diagnostic decision making, the other one is the treatment decision making, which we call in our terminology is called the AI radiology companion. It is a RAD companion, and then it helps the radiologist in finding the diagnosis part of it, and the pathway companion is specifically for the treatment portion and then in the hospital. So now look at this. As I said that we have to first have the scan of the patient, and then once the scan is done, it produces an image, for example an X-ray image or an ultrasound image or a CT computer tomographic image, a magnetic resonance image, whatever it is. I mean, whenever there is a specific problem, the doctor, once he knows that this is what is the patient history is all about it, and then he will suggest a specific problem, a test, saying that this is the test you go through, and this could be any of these tests which I mentioned, and these produces certain kinds of images. And once that data is uploaded to the cloud, and there a lot of AI algorithms are run to quantify the problem and also really understand what the radiologist used to do that this is the problem and this is the how you to identify each segment, each this is the real problem with the particular patient, and he identifies a lot of marks and then etc etc. So all these things can be done by AI, and once that is done, that is transferred back to the radiologist wherever he is sitting, or the physician where he is sitting, to come to the final analysis of that, and whether he agrees with what AI has said it, or he disagrees with that, or if he wants to further improve it, etc etc. So by that way, what happened is that the lot of time which you used to spend only in doing this, now a lot of things has been taken care by the AI, so that he can spend time with the with the patient and then come to a quality decision. And the AI also gives a lot of accuracy, and then so the all these cognitive factors which can lead to a diagnostic errors also removed, so that it helps in the precise diagnosis of the patient. So just to give you an idea that the multiple organs can be used, can be diagnosed, either it could be a chest or a lung or a heart or a prostate or a kidney. Many organs, specific diseases related to these organs can be now analyzed for the abnormalities in the particular specific organ, and also specific measurements can be taken, and all can be done through the AI, and then find out the real problem with the patient. So this is how one can really reduce the load on the physicians, to say that okay, and then help them to make the right decisions. So this is one of the AI applications on the cloud and in the particular healthcare field. Now I come to the treatment side of it. The treatment side of it is that the lot of devices and a lot of ways you can generate this data, and then we need all that data to really understand what is the right path a patient has to take. And then so first we need to aggregate the data. The data come from, again, as I said, that it could be from the scanners, it could be the laboratory data, that is blood tests, urine tests, or a genomic data, or multiple ways you can generate those data. But all this data is required for a doctor to find out what is the real treatment path. And then so we needed this aggregation, and we needed a correlation between these particular different sources of the data, so that we can come to the right decision making process. So all this done through AI systems, and then so we can really now find out that the correlation, and come to the decision making by the multidisciplinary experts, so that they can come to the right decision, and then so the treatment path can be used now to give this right path for the patient to follow. I specifically give an example of a cancer treatment, and then where the correlation between the radiology and pathology data has to be done, to find out what is the real patient risk, what is the risk stratification we call it. And then so that once we know what is the risk this patient is having, then we can really map, because the multiple ways you can treat a patient in a cancer treatment. And so what is the right path? So this is how first we correlate and then assess the risk all through AI, and then also the AI suggests, okay, this is the right medicine, or this is the right treatment, and then go ahead with this, right? One of the treatment paths, and then the disciplinary experts now can say that, okay, this is the path which we take. And then this is all based on the real data, and also an informed decision making. Just to show you a similar kind of an example, where we said that a Google map can solve so where we are and where we want to go. So this is exactly the same way in the medical world. If you can somehow plot all the paths to the recovery that a patient goes through, so fundamentally it has gone through some treatment, now there are multiple paths, and now the AI pathway companions will tell us exactly what is the right path for particular patient, so that he recovers well. So this is how it is seen as the GPS of this medicine. And then so I come to the original questions, that how am I and what is my path to health in the cloud, as well as the role of AI in this thing. So what this AI does is to bring this knowledge and it also helps in building a trust between the patient and physician. And again, it needs to be emphasized that everything has to be dealt with empathetic view. And then, because in a hospital, between a relationship between a patient and physician involves a lot of empathy. So in order to answer these two questions, we need cloud. And I also told you how AI is helping in this cloud in the healthcare world. So now with that, I conclude my talk on this, and I'm ready to any questions which you have it on this. Thanks a lot. And then I'm very sorry for the technical disruption that has happened on, especially it is on my side.
Yeah, thank you very much, sir. Despite the technical disruption that happened, you have managed to enlighten us a lot on, artificial intelligence and how it is collaborating and how it is supporting the healthcare system. Thank you very much for your time, and we look forward to more such interactions with you.